Welcome to Scan Today's Let's Talk AI podcast, where you can hear from AI researchers about what's actually going on with AI and what is just clickbait headlines. This week, we'll look at various ways in which the field of AI is continuing to make progress. I am Andrey Kurenkov, a third-year PhD student at the Stanford Vision and Learning Lab. I focus mostly on learning algorithms for robotic manipulation. And with me is my co-host.
I'm Sharon, a third-year PhD student in the machine learning group working with Andrey. I do research on generative models, improving generalization of neural networks, and applying machine learning to tackling the climate crisis.
I hope you're doing well, Sharon. And we'll just go in and dive straight into our first topic of conversation, which is this paper titled Towards Trustworthy AI, Mechanisms for Supporting Verifiable Claims. So this paper touches on the problem that AI systems, which have advanced a lot in the past decade, now pose many risks when they're deployed out in the real world. And so in this paper, which has been co-written by something like 80 co-authors and many, many labs and organizations, it's a real joint effort. There's a discussion of what practical mechanisms, what practices different organizations, such as companies, can employ to avoid misuses and problematic applications of AI. Some of these mechanisms include third-party auditing of AI systems, red team exercises, bias and safety bounties, sharing of AI incidents, audit trails, and enforcement of interpretability. The authors believe that the implementations of such mechanisms can help make progress on a multifaceted problem of ensuring that AI development is conducted in a trustworthy fashion. This is somewhat different from what has been happening a lot in AI in the last several years, which is a lot of organizations developing statements of ethics and principles, which say what you should and should not do with your AI, but not really concrete practices and mechanisms to implement in your organization. So Sharon, I wonder, what do you think about this overall effort by all these authors, and is it actually a step forward from what we've been at for a while now?
I think it's a fantastic effort. I don't think it's clear to me yet whether this will be a step forward. I think it's great that these institutions are coming together and putting a document like this together and staking a claim into, hey, this matters, because I think it does matter quite a bit. But I will say it's not clear to me that this will move the needle, but it will perhaps be one of many things that do contribute to something that does move the needle.
Yeah, I agree. I think obviously it's still a set of recommendations. So unless they are actually implemented, there won't be actual progress. In that sense, I think it's a good sign that so many different labs and big names collaborate on this. So it shows that a lot of parties kind of signed on to this set of ideas and to push them in a broader AI community. I'm also curious, some of these ideas, such as third-party auditing of AI systems, red team exercising, bias and safety bounties, these are new ideas to me. I haven't actually thought of these as ways to enforce AI safety. So I wonder, what do you make of these? Are they novel to you? Do you think they seem promising?
I think in industry, these are actually quite common methods for evaluating security. And I've seen them time and time again. They're tried and true methods. They're not, I would say, novel, but perhaps they are novel from a research perspective within the AI community specifically, which is what I see these groups and institutions and individuals are coming from. So I think from that respect, and that is valuable, and perhaps this would give that kind of valuable insight into this is how other people are doing this now. This is how these are tried and true methods that have worked in security, and that could perhaps work, and not only just work, but here are ways to actually deploy that effectively. Maybe not effectively, but actually here are ways to actually think about this in the framework of AI.
Yeah, that's a good point. So for instance, bias and safety bounties are very similar to vulnerability bounties, which are done in security to catch hacks of systems. So yeah, some of these ideas, or pretty much maybe most of them, are not entirely novel, but I haven't seen them in the context of AI. in the discussion so far. So I do think it's kind of interesting that they explicitly said, let's take these ideas from these other communities and actually start doing them in the context of AI.
Have you had any personal experience with the overbilling claims you've seen made about AI, either in academia or industry? I'm sure you have.
I do. There are various cases. There was the case of Cambridge Analytica is kind of interesting in the sense of when that story blew up, there was a lot of concern about the degree to which they influenced the political moment. But it's kind of drowned out in that whole conversation was that the degree to which they could influence people and change their minds through data science and AI was maybe overblown. It's not like they are capable of completely changing someone's opinion just by having the data. And at many points, there were overblown claims. So if there were some ability to audit and get data and do more actual concrete investigation in that case, and I think in many other cases, that can make clear the capabilities of an AI system and its flaws and limits, that would be quite helpful.
Right. And I've definitely seen this in the self-driving car area. Basically, some companies might come out and say, hey, we have this many takeovers per 100 miles. And then another company says, we have fewer takeovers per 100 miles, except the former company, the first company with more takeovers, which means that a human had to take over and drive because the autonomous system was not good enough. They were testing in some city, but the other system was with fewer takeovers, and they said, oh, our system is better, was tested in basically Mountain View or, like a place where there isn't much traffic and is pretty easy to drive in. So I would say like those are not very comparable. And so some kind of auditing could help immensely with something like that.
Yeah, and I think that's a good point of self-driving cars, where that's almost a case where some sort of thing like this is necessary to be able to trust these systems at all. So I think these recommendations seem to be in part what companies and organizations could do to sort of self-regulate, but this also interacts with what government regulation could enforce AI companies to do. So the auditing could be done by a third party that is from the government, for instance. One thing that I think is kind of interesting to point out about this report is that most of the offers are from academia. There are a couple of industry players like Google Brain, Google Research, Intel, Rand Corporation, but many of the big names in the industry, such as Facebook, such as many other big companies, are not on it. So I wonder, do you think there will be success in turning, I guess this mostly applies to industry or to a larger extent than academia. So will industry actually take up these mechanisms and practices and go with them?
I'm not sure. So I think industry, if they do move forward, it's not clear to me how much they look to academia for these types of recommendations, especially when it comes to deploying things. I would be more convinced if they actually took up the same principles shown here, but from talking to their friends in security, as opposed to reading a paper. But I could be totally wrong there. But I would imagine that's the case, because deploying something is very different from stating something in research, more or less hypothetically.
That's true. I do think one of the neat things in this report is there are so many offers. Some of them are primarily from policy. So for instance, Miles Brundage or Jack Clark, these are people who deal with ethics and policy of AI. Jack Clark was actually a reporter previously. So some of these co-authors do have expertise, not just in research of building fancy neural nets and AI systems, but kind of thinking about other fields and ethical implications and so on. So I do think the ethical perspective is useful, kind of taking it from people who think a lot about how to avoid negative consequences. But at the end of the day, it will require AI developers to sign on, which is a difficult process.
Right. But I can see researchers signing on to this and starting to think more about how to include this into perhaps research practice or into, for example, how NeurIPS now has a broader impact section, like changing the format of how we view research too within AI.
That's a good point. And in some ways, actually, it's a good thing that there's so much kind of cross collaboration between industry and research. Like researchers in academia go and end up working in industry or end up being researchers in industry. So if these practices start in academia and people kind of are aware of them, they can maybe bring them over, and it will naturally kind of become a norm, hopefully.
So on to our next article called "Computers Already Learn from Us, but Can They Teach Themselves?" from the New York Times. So while AI has impressed us with incredible results from image recognition to game playing, there's one thing that these systems have in common that prevent them from coming close to being considered quote unquote human level. And the TLDR of this article is that supervised learning still can't do many things that are simple even for toddlers. In particular, many of these AI systems have been quote unquote handheld when they're trained through the process of supervised learning. So while we've had great success in teaching computers to see these patterns, there's a whole lot of ground left on the front of getting computers to learn with less supervision, much as a baby learns to walk. For example, using self-supervised learning or reinforcement learning. And many prominent AI researchers believe that this sort of learning with less and less supervision is the next step for AI. And David Cox, the IBM director of the MIT IBM Watson AI Lab, has said, "We want to move from systems that require lots of human knowledge and human hand engineering towards increasingly more and more autonomous systems." So given these different approaches to machine learning, supervised, unsupervised, neurosymbolic AI, RL, et cetera, across all these different paradigms, Andrey, what seems most promising and why? And could you talk about some of the benefits and drawbacks of these different approaches?
Yeah, sure. So to expand a bit on the setup here, right, supervised learning just means that we have a lot of humans give the answer to the question first. So you have a lot of input examples, you have humans who label the answer for each of those inputs, and then you just crank through the data and learn. And these other things like self-supervised, neurosymbolic, reinforcement learning, all basically mean that you have less direct human annotation and less direct involvement of humans in the learning process. Personally, I'm not sure which of these things is going to be useful. Maybe it's going to be a mix ultimately that's required to really make progress. My own research deals a lot with reinforcement learning, and there's still a lot of human engineering in terms of setting up the reinforcement learning problem, setting up a reward signal, setting up the action simulator. But at the same time, I do think there's been a lot of progress recently in machine learning with less supervision. So for instance, we've seen unsupervised learning, which means that there's just no labels, there's just data. So just images, for instance, becoming much, much better just over the last few months. Actually, papers have been coming out showing that what used to be only doable with a lot of supervised data where you have labels for each input, now with enough data, if you learn in an unsupervised fashion, just with the input data, you can learn enough about the structure of images and their contents to be able to solve many of the same tasks as efficiently, but without any of the labels. So that progress has been really very promising. I wonder, how does this relate to your own research, Sharon?
Yes, this relates quite a bit, especially the unsupervised part. So generative models, GANs, generative adversarial networks, kind of fall under that paradigm. And they have seen wild success in many ways with deepfakes, but also hopefully with slightly less pejorative applications associated with them, but basically being able to produce simulated real content in across different media. And that has been very, very successful, so to speak. I have been getting more and more excited about self-supervision personally and reading papers on that. It's a really interesting area of, I think there's still a bit of hand engineering going on, where people kind of specify what those self-supervision signals are to the model, but the model is able to learn from itself as well.
Yeah, and just to fill in that a bit, self-supervision just means that you have the data and then you make the algorithm kind of fill in something that's missing, for instance, something like that, where you kind of have a fill in the blank type thing from the data. So you don't need any extra labeling. You just take what you have and learn from that.
Right. So it produces its own labels in some sense. And one really simple, quote unquote, example is to even think of a video as bidirectional. So you can train one direction and also the other, and that's not giving any more labels.
Yeah, I think self-supervised learning definitely is very cool, and likewise has been making a lot of progress. Just recently, actually, there was a paper combining self-supervised learning of visual representation, so like understanding what's in images, with reinforcement learning, and showing that reinforcement learning can therefore be much more sample efficient. So by executing many fewer actions, by interacting with the environment much less, because you're also learning with visual perception or self-supervision, you can learn much faster. So it does seem like we are in a time where these ideas that are not pure supervised learning are getting a lot more traction. And maybe to close, I'll also touch on this topic in an article of robotics. So it cites Sergey Levine, who is a very well-known professor at Berkeley who works on robotics. And he talks about how the ultimate hope is, of course, to have robots that can do kind of the things that we as humans do, and so on. And in theory, you could have a robot learn just like a baby by playing in an environment and kind of just spending time in it until it learns to walk and do various things. And yet we are still very, very far from that paradigm. So far, we really are hand engineering these specific rewards to guide the robot or agent to learn things. So I think this shows us kind of a direction to go toward, where robots could hopefully learn from themselves, but also shows how far we are from that point, and that we shouldn't be overly worried about robots that are able to do anything in the near future. But to focus a bit more on the present instead of a future, we're going to go on to our next article, which is from Scientific American, titled AI Will Help Scientists Ask More Powerful Questions. And the gist of the article is basically all about the various ways in which AI and deep learning can help scientists in other fields, so biology, medicine, physics, etc., do science, discover new things with the aid of AI and deep learning. It has many examples. One of them is actually COVID-19, which is a great challenge, and there's a lot of science that needs to be done in terms of medicine and the drugs to treat it. And that's an area we've already discussed where AI is helping. So I wonder, Sharon, you work a bit on climate change, which of course is a pretty big scientific area on its own. What have you seen on this sort of interaction between AI and other scientific fields?
Across the past year, I've seen some really, really positive things come out from collaborations. I've seen people push for stronger and stronger collaborations between AI machine learning experts and those in the climate science fields who are working on either climate science or mitigation or adaptation for climate change. So that can span the energy or system sciences and atmospheric sciences departments, in addition to many, many different others. And we interface quite a bit with the School of Environmental Engineering here at Stanford. And we work with professors across all these departments. And I've just seen more and more collaboration at this intersection. And I've seen folks push for this collaboration more and more as well. And so that's been really exciting to see. And we pushed out, different workshops on AI and climate change at these AI conferences. And that's helped promote that's helped promote this work at this intersection too. But it definitely requires pretty heavy collaboration and hands-on collaboration and a willingness to learn quite a bit about what the other side cares about and is working on, and how they frame problems. Yeah, before something can probably come of it. So it does require that willingness to collaborate quite deeply, but I see it, and that's really exciting.
Yeah, that sounds super exciting. And I'm a little jealous actually that you get to see this kind of firsthand. I'm a little more deeply embedded within the AI community, and I don't necessarily interact with other scientific fields. But on the other hand, I do scroll Twitter through a lot. And so it's been interesting to see various examples of, for instance, in neuroscience, AI is now becoming quite helpful for modeling things in the brain and for actually helping us understand AI systems. I've also heard a lot from one of the professors in my lab, Fei Li, who is a huge proponent of integrating neuroscience and cognitive science and AI and really taking inspiration from those scientific fields as we develop new AI algorithms. And that's actually one of the goals of this new human-centered AI institute at Stanford, is to make things more interdisciplinary, help scientists from different fields interact with AI researchers.
Yeah, and I think the COVID-19 crisis has also brought people together from the School of Medicine and folks doing AI here at Stanford and also at large, right? I see much more openness and willingness to collaborate and help towards this medical crisis. And that has been enormously helpful. And according to that interview we had on Skynet today, with professor and doctor, has been helpful towards the medical field, and the medical field has very much appreciated our willingness to help as well. So hopefully that continues.
Yeah, that's a good point. This moment really does clarify how AI can interact with other fields and various systems and really integrate, and you need the expertise at both sides to make it work. Another example we've discussed is how now you have a lot of these robots being deployed in hospitals, and you really need to understand how the hospital works, how nurses there work to be able to operate there. And in some ways, that's similar to scientists, where you need to understand the workflow of a scientist, what are their problems, what are the challenges, to develop AI techniques that they can then leverage to make new discoveries. I'm curious, Sharon, have you firsthand worked with people from climate science in developing your models? Or what kind of work has been in your papers, which I have actually sadly not read yet?
That's totally okay. Please don't read them. In our lab, we work with both healthcare professionals and also those on the climate change side, working on climate science, climate mitigation, and climate adaptation. And on both fronts, on both of those branches, we work very, very closely with those domain experts. So we have them in our Slack channels. We are constantly updating them on things, and they update us with things. We often cater to wherever they would like to publish. So whatever would help them in their field is generally how we view it. And we view ourselves as, how can we support them in advancing their science? So that's largely how the collaboration is structured, I would say.
I see. Have you found it challenging at all to try and get some of the domain expertise from their field and understand their side in addition to the AI side?
Yes, definitely. It's a exponential learning curve for sure. In the beginning, you think there's no possible way I will be able to understand half the words that they're telling me, even after a year of working with them, but you do. And soon you understand what an eddy covariance tower means working with methane sensors, and you understand all this. But in the beginning, you walk in and you realize, wow, I know nothing about this field. I know what I know, I'm pretty sure is just some pop science article I read. And so I know that there's something wrong with it. And that's what I know going in. And then I learned so much over time, and the curve is definitely exponential, or at least feels so. At least for some point. It's a very fast learning curve, and it's worth it. And they also learn too. A lot of them often come in with a very rudimentary view of AI, or think that AI can solve anything. And we start to chip away at, what are some perhaps easy wins we could make together, just to establish the collaboration and to start to understand what the other side can do, and what are the both strengths and limitations of both sets of tools and applications, and what the constraints are, and what's valuable, and prioritizing what's valuable in terms of what we build.
I see. Yeah. That sounds really, really challenging, but hopefully also really rewarding once you get things to work with a collaboration. I think we've noted a little bit, and there's been a lot of discussion in AI, how there's been a bit of a problem where one of the cornerstones of AI research has been just chasing better results and better numbers on some existing data sets, which can in the end result in not doing real science, just sort of engineering and hacking to try and get diminishing returns in terms of improvements. So people like you actually doing the hard work to go to areas where AI has not been applied and figure out how it can be, and doing that work, which hopefully we'll have more and more of in this next decade, that actually does point to a lot of progress we can still make with AI.
I agree. And with that, thank you so much for listening to this week's episode of Skynet Today's Let's Talk AI podcast. You can find the articles we discussed here today and subscribe to our weekly newsletter with similar ones at skynettoday.com.
Subscribe to us wherever you get your podcasts, and don't forget to leave us a rating if you like the show. Be sure to tune in next week.